Hello. Hey, let's talk about naming organic compounds by assigning them a standardized or IUPAC name. Okay, so this takes us to Key Concepts, Unit 1, Part 3. This handout is on Canvas. There's another handout just on naming by the IUPAC system. So take a look at that too. I'll be taking excerpts from that document as well. So 2 documents to look at today. All right, so in a previous video, we talked about common names. That went okay, but once the molecules get too complicated, too many decorations, other groups, functional groups on those compounds, then the common names just becomes too confusing, too cumbersome. So most of the time when we have to assign a name, we're going to use the standardized name or the IUPAC. IUPAC stands for International Union of Pure and Applied Chemists. So International Union, yeah, the International Committee of Chemists got together and they sat down by committee vote on how are we going to assign names to compounds. And they developed a procedure that works pretty well. Sometimes, you and I are going to look at these rules, these ways, this procedure, and question it. And just remember, it was voted on by committee. And in a committee, you have to make compromises. So sometimes the best ideas don't come forward. Sadly, this is what we got to work on. It's pretty good, but it has some flaws. We'll bring those up. Let's see, this is a fun little meme here. Let you freeze the video and take a look at that if you like. Fun. Okay, here's the little excerpt from the other handout called, I think I call it Nomenclature or Naming Organic Compounds on Canvas. It's a quick little breakdown on what consists of an IUPAC or standardized name. This is pretty good. Right here, there's 3 parts. If you look at a name like this one down here, the name I'm giving as an example is 1-chloro, 2-methylpentane. What's this name all about? Well, most of it, at least in this case, 2/3 of it, consists of prefixes. And the prefixes are telling you where they are by the number and what are they. Well, on carbon number 1, there's a chlorine group. That's a double check mark, sorry. And on carbon number 2, there's a methyl group. Okay, the chloro group, well, that reminds you of chlorine. And methyl, well, when we named compounds by the common name kind of rules, if you will, methyl stood for a 1-carbon group, an alkane. And so that's the same thing here. It's a 1-carbon group. So there's an additional carbon attached to what? To the parent. So in the IUPAC system, what you're going to first do when you assign a name is look at the whole molecule and try and decide where is the longest sequence of carbons. We'll talk more about that in a minute. And it also has to possess the most important functional group. Okay, so the parent chain is the longest chain with the most important functional group. And we assign it a name, and it begins with those 10 alkane names we had to memorize. Yep, we're going to use them. So methane, ethane, propane, butane, Mabel eats peanut butter. And then pentane, hexane, heptane, octane, nonane, and decane, like a decade. So you still have to remember those 10. Those will be your parent names, except in the future, as we cover the naming of more complicated molecules containing multiple functional groups, we're going to break off the suffix ane of pentane and add another suffix or attach an additional suffix. Leave ane in place and add another suffix to represent the most important functional groups. Okay, don't panic yet. I just wanted you to see just a main idea. Standardized name has a whole bunch of groups right in front of the parent, which is the longest chain with what? The most important functional groups, which are identified by a suffix. And methane, ethane, propane, butane, those are all alkanes. And so alkane, A-N-E, yeah, the suffix ane represents, hey, the most important functional group is the carbon-carbon single bond in those molecules? The alkanes. Cool. But as we add more and more functional groups, it'll be important to know, well, who's more important? And there is a list. I supply that list to you on Canvas. I don't recommend memorizing it. Instead, look for patterns. And the pattern is, there it is, there's my marker. In general, the more oxygen atoms a functional group has, the more important it becomes. So for example, the order IUPAC declared order of functional groups priorities begins with carboxylic acid. That's more important than an aldehyde, more important than alcohol. And you ask yourself why? Well, the other thing we had to do was memorize functional groups. Carboxylic acid, we had to remember, is a C double bond O attached to another oxygen with a hydrogen. The aldehyde is also a C double bond O, but has a hydrogen. And then there'll be a carbon on the other side. The alcohol group is simply the OH group. And you can see that carboxylic acid wins, highest priority because it has 2 oxygens. And then you'll say, wait, aldehyde and alcohols also have 1 oxygen. How come the aldehyde is higher? Because the other pattern is more pi bonds. So the double bond and a triple bond functional groups are generally higher priority, higher ranked than single bonded functional groups. So that's the pattern. More oxygen atoms, use that to kind of declare which ones are more higher ranked, higher priority. And then if you have a tie like we did with the aldehyde and the alcohol, decide if one has more pi bonds. Yeah, the aldehyde has a double bond. A sigma and a pi bond make a double bond. Cool. Okay. Not necessarily something you have to memorize. Oh no, carboxylic acid, aldehyde, alcohol. No, just remember more oxygens, more pi bonds, and you'll just naturally arrive at the correct order. There are a couple of exceptions to that, but we'll deal with those when we have to. Okay. That's kind of the outline of the rules, not rules, the format of the name. Yep, right? Yes. Sorry, talking to myself. Okay, now, there's a couple of different ways we can proceed. One way that most textbooks do is they'll say, hey, let's start talking about naming, but only talk about the alkane group. Okay, so then we learn how to name alkanes. And then next chapter, oh, now let's talk about alkenes, carbon-carbon, double bonds. Ooh, and now the rules have changed. You learn those. And then the textbook will move on. Well, now let's talk about alcohols. And oh, guess what? The rules are going to change yet again. I don't like that procedure. It works for some people. As a student, it didn't work for me, and sorry, low bias here. I'm going to present it in the alternate way. And this is where I give you all the rules now, so you have them. The rules don't change, but there's a lot of details. So what we're going to do now is just read through these rules, and then we'll break out the portions of the rules that we need for alkanes. And that's what we're going to do today. We'll name molecules that only have alkane and halides as functional groups. Okay? All right, here we go. Again, this handout, these rules are on Canvas. To identify or determine an IUPAC name, that's when you are assigning it. You have a structure and you have to name it. First thing you want to do is identify the longest chain or ring that contains that highest priority functional group. And that becomes your parent chain or ring. Okay, today we're not going to deal with rings, right? Carbon-carbon chains that actually attach end-to-end to make a ring. Yeah, those molecules exist. We'll learn how to name them later. And then, so we're going to find this, maybe you have this molecule that has lots of branches. You're going to have to find 2 ends of the molecule and see what's the greatest number of carbons between those carbons at the end. I got examples coming. And if you have a tie, then choose a chain that has more branches. I don't have examples of that today. More on that later. Step 2, now that you've found the longest chain, name it. So in my class, the longest chain will have 10 or fewer carbons because those are the names I asked you to memorize, right? methane through decane, the 10 alkanes. And then in the future, not today, in the future, we're going to see other functional groups in addition to halides and alkanes, and then you'll have to add the correct suffix to identify that other functional group, the highest ranked functional group, the highest priority functional group. Step 3, we need to number the chain. This is going to help us tell where extra branches or extra groups are. And the idea is it's like playing golf. You want a low score, so you need to number the chain from the end. It gives the lowest number to the highest priority group. You kind of want a hole in one. So if it's possible, try and get that highest priority group on carbon number 1. It is not always possible, but that's the objective. If you can't put it on carbon 1, like the functional group's not on the end of a chain, someone drew it and it's somewhere in the middle, well then choose the end that can get you to that group as fast as you can in the lowest number. More examples are coming. And then at step 3 here, where we are numbering the chain, that becomes really critical and kind of confusing. By committee vote, what they decided is that they said, hey, alkyl groups, alkanes, and halides have equal priorities. Meaning if you're trying to find the most important functional group and you have alkane branches and halides, they're equal priority. And so what we're going to do is if you're numbering from either end and you hit one of these branches, whether it's a halide or an alkane branch, find the first one you can get to. And if it's a tie, now find your second branch. And which one can you get to faster? The lowest number. And that'll break the tie. And if it doesn't, if it's tied again, then go your third branch, your fourth branch, whatever. And if it's completely tied, based on how quickly you can get to a branch from the end of the chain, then you break the tie alphabetically. So don't use the alphabetical tiebreaker until the very end. Deep breath. We'll do a lot of practice with number 3 in this video. After we numbered the chain, what do we do next? Well, you walk down the chain, the parent chain that we named, and at every step, see if there's extra decorations on the molecule. See if there's extra groups, branches, and for every branch, you need to name it, and then you need to number it. That's step 5. Step 4, there are a few details. If we have 4 chlorine atoms, and the chlorines are appearing on carbons 2, and on 3, and on 4, and on 5, and we have to name it, well, we don't want to say the chloro word 4 times. Let's just say it 1 time. And then we're going to stick a prefix tetra in front of it to say, hey, tetra means 4. So tetrachloro means there's 4 chlorines there. We have some examples of this too, all these details. Okay. We got a little point here in my handout about complex substituents. This is just the catch-all. In case a molecule is super branched and complicated, there is a way out. In my class, my introductory chemistry class, we rarely use complex substituents as a tiebreaker or as a way to name molecules. Usually, the molecules are not as complicated as you might need this step. Again, if I've lost anyone, just kind of force your way through. Sorry, let's get to the end of these rules, and we're going to practice them, and we'll make some sense. We're still in step 4 where we're naming branches, and here's some examples. These are the most common branches in my class. I mentioned that the halides are going to show up. Well, the most common halides are right here: fluorine, chlorine, bromine, iodide. And all you do to name them properly by the IUPAC naming system is drop the suffix -ine and add the letter O. So if a fluorine atom shows up in a molecule, we name it fluoro. Oh, and just so you get the spelling right, it's a U before the O. My teacher told me that fluorine has the flu, or fluorine. And then chloro, bromo, iodo, those are the names of the 4 halides you'll see in my class. And then if you have a 1-carbon branch, meaning if it was a parent, 1 carbon would be methane. But the methane, the ane ending is reserved for the parent, the longest chain. So if you have a long chain and there's a 1-carbon branch, we don't say there's a methane branch. We say there's a methyl, YL ending. We kind of borrowed from the common names. Same true for ethane. Well, if there's a 2-carbon branch off of the main chain, the parent chain, that's an ethyl branch. 3 carbons, well, you could have this long chain. That's a crazy chain. And then let's make it a little longer in case you inspect this later and you want to name it. From here, we could have 3 more carbons. Right? So here's my parent, the longest chain. And then I got another 1, 2, 3, and I shouldn't be numbering them because you're only supposed to number the main chain. But I wanted you to see that there's 3 extra carbons attached to the parent chain. And because they're all in a row, we're going to call that a propyl branch. And if there was 1, 2, 3, right, there's a carbon here, here, and here, these 3 atoms are also branching off the parent, but they're connected to the parent through the middle carbon. That's going to be called an isopropyl branch. Yeah, for those of you who remember the video on common names, there was 4 common names for a 4-carbon chain. There was butyl, isobutyl, sec-butyl, and tert-butyl. Okay, and then if you're thinking, what about pentane? Now, there's pentyl. You might see that on one of my exams. But it'll always be, if it's pentane is a branch, it will always be 5 in a row. I'm not going to branch. Yeah, it won't get super complicated. If later in your chemistry or science career, if you have to name something that's really complicated, that's when you would use a complex substituent. Not covering that today. Okay, enough detail about step 4, naming the branch. After you name it, just say, hey, where is it? What number of carbon did that extra group, that branch, come from? And then finally, okay, so that's number 5. And then step 6, now you have identified all the branches and you've named and numbered them, put them in alphabetical order. And then after you alphabetize them out in front, anytime you have 2 numbers colliding, use a comma to separate those. If you have a number next to a letter, use a little dash or hyphen to separate those. And think of it as like the grammar. Excuse me. You got it all? Yeah, me neither. When I was a student, it's like, all these rules. Naming is more like a skill than something you have to memorize. So definitely, it gets better with practice. Okay. Let's first of all restrict ourselves to naming organic molecules containing only 2 functional groups, alkanes and halides. When we do that, the naming rules simplify. That's good. Okay, if you only have an alkane or a halide in your molecule, the rules simplify to this. Step 1, find the longest chain. Where's the longest sequence of carbons? Step 2, name it, and you gotta have those 10 alkenes memorized, from methane, ethane, propane, all the way up to nonane and decane, because that's gonna be your parent name. That's step 2. Step 3, okay, you've named the parent chain, number it. And you have 2 choices. Number it from the left end to the right, or number it from the right end to left. Ooh, which one's the correct way? You number it in a way so you can arrive at your first branch as fast as you can. What if you name from the left side and right side and there's a branch on both sides on carbon 2? Well then, where's your second branch? How quickly can you get to the second branch? If you can get to it faster on one side than the other, then the side you get to it faster is the correct way to number it. Examples are coming. After that, after you named and numbered the chain, the parent chain, now walk down the chain. Are there extra stuff, decorations I call them, other alkanes branching or other halides? And if so, say, hey, for each extra branch, extra group, where is it branching off from the parent, what numbered carbon, and then what's the name for it? And over here, right in the middle of the screen, where's my mouse? Right here are all the prefixes. Ooh, all of them? No. These are most of the prefixes you'll need. Those are the most common ones. And today, these are all the ones you need. Let's see. We'll have to add the di-tri-tetra in case a group shows up more than once. That's steps 4 and 5. And then finally 6, hey, construct the name. Group all the prefixes out in front of the parent, put them in alphabetical order, and then use a little grammar, if you will, separate numbers with commas, separate a letter and number with a dash. Ready to give it a try? You bet. Okay. Got those names, the rules over here on my left, just to reference them. Here is the exact same molecule drawn 5 different ways. Okay, this is one of the reasons why the names are the naming rules are kind of complicated and full of details. The objective is that no matter who draws it, in whatever fashion, right, whether it be by a full structural drawing, or a skeletal drawing, or a mixture of condensed and skeletal drawings, right? When you draw it, you decide how you want to draw it. But no matter how it's drawn, we have to come up with one unique name every time. No matter how it's drawn, it doesn't matter how it's drawn. If it's the molecule, it needs its proper standardized name. And these rules are designed so that no matter how you draw it, you should arrive at the correct name each time. Only if we're comfortable applying and using the naming rules correctly. Okay, let's give it a try. Step 1, find the longest chain. Okay, well, now you have to pick which one. I already told you these are all the same. So do you want to work with this one? Actually, let's do 2 of these. Let's do this one first. Okay, the longest chain. Well, here's an end of the chain, and here's an end, and here's an end, right? And so technically speaking, to be very mechanical in my thought process, there's 3 ends of this molecule, so we should look at all 3 ends. So starting here and going to here, there's 1, 2, 3 carbons. Starting from here, ending here, there's 1, 2, 3, 4 carbons. And then finally, from here to there, there's 4 carbons again. Okay, the 3 carbon chain loses. That's not the longest. There's 2 ways at getting at 4 carbons. Okay, so the tiebreaker was pick the chain with the greatest number of branches. So we can either pick this chain, group of 4, or we could have picked this one. And they both have 4, and they both have 1 branch. It turns out in this case, you'll get the same name no matter how you decide the longest chain is. This works out that way. Okay, so in this way, so if you wanted to number it this way, you might, or you wanted to find the parent, you might decide that's my longest one. And someone else might say, no, this is my longest one. Right, you could number it this way. Or you could have done it this way. Turns out we're going to get the same name as long as they both have a chain of 4 and 1 branch. Okay, we found the longest chain, and there was, unfortunately in this example, there was 2 correct answers. The one in the straight filled in lines or the dotted lines. Well, let's continue with this structure. Like I said, all of these parent chains are going to work. Step 2, we found the longest chain. What's the name of that chain of 4 carbons? Butter. Mabel eats peanut butter. Oh wait, no, it's methane, ethane, propane, butane. The parent name is butane. Cool, that's step 2. Step 3, number the carbons from the end closest to the first branch. Okay, so here's my parent, I circled it. there are two ends to the parent chain. See the left side? 1, 2, 3, 4. So coming in from the left, I reach the branch at carbon 3. Or I could have started on the right. 1, 2, 3, 4. And coming in from the right side, I get a number 2. That's a lower number, which means that's the correct way to number. There's a branch on carbon 2. If we number this molecule, we already know, number it from the side closest to the branch. This is a 1, then a 2. Finish numbering the chain, 3, 4. From here, oh yeah, you have to start numbering down here. Yep, the branch is on 2 again. This one, let's see, it'll be on this carbon. That's 1, then 2, 3, and 4. The branch is on 2. And this one I got all messed up. I'm going to skip it because it's just so messy. But this is definitely carbon 2, 3, 4. And then you decide, was this number 1? Because in bold, that was my parent. Or the dotted line, was that your parent? And this is 1. All right, that was step 3. Step 4 and 5, name and number that branch. Okay, let's work over here. So what the heck is this name? The name of that branch. A 1 carbon branch. That's Mabel. Wait, that was methane. Mabel eats peanut butter. Methane, but methane is a parent name. You don't call that branch methane, you call it methyl. Kind of like the common name. Cool, so the name of that branch is methyl. Where is it attached to the parent? On carbon 2. And I finished step 4 and 5. I've named and numbered the 1 and only branch. It's a 2-methyl group. Step 6, put all the prefixes in front. Well, that's a 2-methyl. Follow it with the parent, that's butane. And now let's get the grammar right. I got the 2 next to an M, that's a number before a letter, that's a dash. And then the L is going to be right next to the B. You smash it all together, no space. Yeah, I know, it becomes one word, methylbutane. And the full name is 2-methylbutane. Yay, did it. 1 down. Let's do another one. Yep, where's my marker? Let's draw 4 in a row. And then I'm going to put 2 carbons branching off like that. And I'll take another 2 carbons and branch it off like that. Cool. So, step 1, find the longest chain. Why don't you pause it and find out where the longest chain is. How many carbons in that longest chain? Did you get 6? Yeah. So the parent does not have to be left right. No one said, hey, every time you write a molecule, you must write it this, draw it this way. Nope, draw it however you want. After it's drawn, then figure it out. Where is the greatest sequence of carbons in a row? Here they are. The chain of 6. That's the parent. Name it. 6 carbons. That's like a hexagon. This is hexane. That's the parent name. 3, number the carbons from the end closest to the first branch. Okay, so there's 2 ends, the top end and the bottom end. Starting at the bottom, since that's where my pen is, this is carbon 1, 2, and then 3. Or up here, start at the top, that's 1, 2, and 3. Ooh, a tie. Okay, IUPAC says, all right, the first branches are tied, find the second branch. Okay, so this is 1, 2, 3. Here's my 4th branch, shows up on carbon 4. But coming from the other side, what I should do, I should change the pen color. Come in from the other side, here's a 1, 2, 3, 4. It's a tie again. Well, IUPAC says go to the 3rd branch. 5 and 6, there are no more branches. 5 and 6. No more branches. Okay, the last thing you do is break the tie alphabetically. Okay, what's the name of this branch? One carbon branch is methyl. What's the name of this branch? One carbon branch is still methyl. It's a pure tie. So it turns out, in the case of pure tie, you can number it in any direction. You will get the same name, whether it's a red or blue. What is this? Purple, indigo, whatever. So a little trivia about myself. I'm partially colorblind, so if you ever hear me mislabel the colors, yeah, my fault. Moving on. Let's see. Yeah, it's another tie. But at least you saw how potentially you're supposed to break the tie. What else we got next? That was numbering. I'm going to go in red. I'm going to start at the bottom and go climb my way to the top. No, let's do it at the top and bottom. It doesn't matter. What's next after we number the chain? Name and number branches. Well, I already named them. There's a methyl over here, carbon 4. There's a methyl over here on carbon 3. That's it. This one is a 3-methyl, separated with the dash, and this one's a 4-methyl, separated with the dash. Ooh, wait. Anytime the same branch shows up more than one time, the name is not going to be 3-methyl, 4-methyl hexane. No, you don't say methyl twice. You only say it one time. Because methyl shows up 2 times, you use the prefix di. Remember, like carbon dioxide. Carbon dioxide has 2 oxides, 2 oxygens. Well, this molecule has 2 methyls. They're both on, well, they're located on carbon 3 and 4. And then those are my prefix and numbers. And then I tack on the parent, hexane. Yep, that's the parent. And now I have 2 numbers stuck together, separating with a comma. I got a 4 next to the D, that's a number in the letter, separated with a dash. And there's the name, 3,4-dimethyl hexane. What's next? Okay, I grabbed this off the internet, so that's why the bond color, the colors on the bonds are weird. I thought, ooh, we could do this one. Step 1, find the longest chain. Go ahead and pause it. Maybe you want to crank out all 6 steps. Give that a try, and then you can compare your answer to mine. All right, here we go. Find the longest chain. There's one end here, and there's another end here, right? It doesn't have to be left, right. I know it kind of looks like a branch, but that's not the end of a chain. There's a carbon above and a carbon down to the right. This is not the end of a chain. There's the end's up here. And so there's 1, 2, 3, 4, 5, 6, 7 carbons in the parent. I like circling it. You circle the parent, stuff that's not circled are branches. Okay, 7 carbons. Step 2, what's the name of 7? The women Olympic event is the heptathlon. So I remember it. This is heptane. 7 carbons. All right, let's number those 7 carbons. Is this carbon 1 over here on the left, or is this carbon 1 on the right? Well, where's your first branch? Ooh, from here. It's right here on number 2, I hit a group. Over on the right, carbon 2, I also hit a group. Okay, it's a tie. So find your second branch. Well, on the right, and that's on my left. Starting on my left, that's carbon 1, 2, 3, 4, 5. I don't hit a branch, the second branch until carbon 5, counting from the left side. So I'm going to get there faster on the right. 1, 2, 3. Found the second branch on the third carbon. This is the correct way to number it. This is 4, here's 5, 6, and 7. Get to that branch as fast as you can. The first branches were tied, found the second branch. And you can get there faster coming in from the right. All right, you found all the branches. Name and number them. Well, walk down the chain. Here's carbon 1, nothing burst in this little bubble. 2 has a chlorine sticking off of it. The chloro group. So does 3, and so does 6. So this one's a 6 chloro, this is a 3 chloro, that's a 2 chloro, but chlorine show up 3 times. 3 wheels on that little trike as a kid, a tricycle, or a triangle is 3. Yeah, tri. Tris are a prefix. So we're going to have 3 chlorines, trichloro. They're located, and then put them in number order. The 3 chlorines are on 2, 3, and 6. And the parent is heptane. Step 6 is get your punctuation right. Numbers are separated by commas, letter for number by a dash. There we go, 2,3,6 trichloroheptane. Name of that funky molecule. And we're just getting bigger and more complicated here. Okay, these two are exactly the same. So coming over here on the left, that's my right. Coming on the right, 1, 2, 3 carbons in. There's a methyl up and a methyl down. There's 2 branches coming off the same carbon. They're both methyls. You can see that same situation over here. 1, 2, 3. There's a methyl to the left, down and to the left, and down to the right. 2 methyl branches. And then over here is a methyl branch down. Those are the same. These are the same molecules drawn 2 different ways. Your preference. Let's see. Well, find the longest chain. Okay, it looks like it's left-right this time, right? Technically, you could say, well, starting here, I got 1, 2, 3, 4, 5, 6, 7. That's an end of a chain. But that only gives me 7 from here to there. But if I go from this end, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is greater than 7. The parent is right here. That's my parent. Ooh-wee. And, well, same deal over here if you want. Actually, no, circle it. But I will work off of this one. Right here in step 3. No, I'm skipping. Don't skip step 2. 9 carbons. Well, sounds like the name for the alkane name for 9 carbons starts with an N. It's nonane. 9, nonane. Now let's number the chain. Okay. It could come in from the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or it come in from the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the 2 choices. Which one's correct? Well, how fast can you get to that first branch? Well, numbering from the left side, I hit a branch at carbon 3. Cool. On the right side, I come in from the right, I hit a branch at carbon 3. First branch is tied. Find the second branch. Well, over here on the right, the second branch is also on 3. One of these methyls is my first branch. The other one's is the second one. They're both on carbon 3. So numbering from the right, I get to the second branch on carbon 3. Numbering from the left, though, first branch is on 3. Second branch isn't until 7. Nope. That's not the right way to number it. Second branch is on 7. No, it's like golf. Keep your score down. This is the correct way to number it. Cool. Name and number the branches. Well, on carbon 3, that's supposed to be a 3. There's a methyl. There's another methyl on 3. And then on carbon 7, there's a third methyl. Add them up. That's 3, 3, 7, tri, methyl, nonane. Winner. And yes, you do have to list both 3s. You'll lose half a point on my exam. If there's a tri, you must have 3 numbers. If you don't, if you just said 3,7, well then do you mean 377 or do you mean 337? I can't tell. You have to list all the numbers. Okay, here's another one. Why did I put this here? Oh, I remember now. Let's name and find out. Where's the longest chain? That's pretty cool. Those are halide branches. All 5 carbons are nicely in a row right here. 5 in a row makes it pentate. That's step 2. Step 3, number it. Okay. 1, then 2, we hit the iodo group. 1, then 2, we hit the fluoro group. Okay, first branch shows up on 2. Where's the second branch? From the left side, fluorine's on carbon 4. Counting from the right side, iodine's on number 4. It's a tie again. And then there's no more branches. What do? Alphabetic order. Alphabetically speaking, fluorine, A, B, C, D, E, F, F, F. Yeah, I didn't say I yet. So F is first in the alphabet. When we're face-to-face in a classroom, I make a joke and say, hey, no singing the alphabet song during the test. Okay, fluorine's first in the alphabet. So the correct number is get the fluorine first over iodine, alphabetic order. That's after we check the branches. You want to get to your first branch first. Check the second branch. If there's a third, check the third. Then last tiebreaker is alphabetic order. Cool. Steps 4 and 5 are to name and number the branches. While number 2, there's a fluoro group. On number 3, there's an iodo group. And then we put them in alphabetic order in our name. Fluorine's got the flu. Did I do this right? 4. Good. I think I did. Iodo. Pentane. Yay. Oh my goodness. That is crazy. Why don't you pause the video and try to name this? And don't get freaked out. All we're going to do is just take a systematic approach, one step at a time. Alrighty, what did you get? Well, technically speaking, you have to start through all the branches. I know that's the, all the ends of the chain to find the longest chain. Technically, you might want to think about, is this the start of the longest chain? No, it's over here. And then it goes up here and goes over here. And just trial and error, trying different chains. I mean, I did have to check and make sure going from here to there wasn't longer, or from down here, bottom left, to the top right. I made sure that wasn't the longest. This is the longest, and then there's 1, 2, 3. Carbon 3, I'm heading a branch. 1, 2, 3. Dang, it's a tie. All right, so I want the parent name, and as I'm counting the chain, I thought, well, maybe I can find the right end. Where's my first branch? It's a tie on carbon 3. Darn it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, this is nonane again. The chain of 9 is nonane. Now we have to number it correctly. Starting at the top right, 1, 2, 3, I get to a methyl branch. On the left, 1, 2, 3, a methyl branch. Where's my second branch? Starting here on the left, 1, 2, 3, first branch. 4 has my chlorine. Hit the second branch of 4. Start again over here on the right. Carbon 1, 2, 3, first branch. 4, a bromine. It's a tie again. Where's my third branch? I know. 1, 2, 3, one branch. 4, chlorine and bromine. So bromine, so the third branch, happened to be a bromine for me, is on carbon 3. I'm sorry, that's number 4. 4. Okay, coming in from the other side. 1, 2, 3. There's a methyl. Bromine is number 2. And an ethyl branch. Dang it. 3 branches in. We're tied. Where's the 4th branch? 1, 2, 3, 4. We got a pair of, we have a methyl and isopropyl coming this side. 1, 2, 3, 4. 3. It's a dead tie. It's a dead tie. Oh my goodness. Yeah. So dang it. Okay. I do not intend to put as complicated a molecule as this on your exam. We're just showing that, hey, you can do it. Okay. So then what are we going to do? Well, our first branch was methyl. first branch, the other side was methyl. Coming in on the left side, our second branch was a bromo and a chlorine. I don't know which one's really, they're both connected to number 4. Is it bromo? Is it chlorine? I want to go alphabetical order. It's a bromine. Coming to this side, our second branch is, well, first one was methyl. Then it was a bromo. Okay, they tied. Here is our tiebreaker. We got a branch here, methyl, branch here, bromo, branch here, that's an ethyl. Our third branch is ethyl. Coming in from the left, first branch was methyl, second branch was bromo, that's tied so far, and then the third branch is chloro. Alphabetically, who wins? C before E. Okay, again, let out all that stress. I'm not going to do this to you on exam. All I'm doing here is showing that the committee, the IUPAC committee, they did a pretty good job. They got a system that's working for crazy molecules like this. Methane, ethane, propane, insane. Molecules like this. Okay, the correct way is a number to get to this chlorine, alphabetical order first. So it's already getting pretty messy. I think I redrew this somewhere else. Let's find out where I did. Did I go down? Did I go up? Sorry. There it is. Okay. So parent chain is nonane. And numbering starts from the left. That's steps 1, 2, and 3. In step 2, the parent name is nonane. Okay, branches. Okay, think about going for a walk in the woods. You park your car, get on the trailhead at carbon 1, we meander down the trail 2, it's kind of boring, and number 3, there's a fork in the road. You want to stay on the main path, so I'm going to head over to number 4, but first I want to just look down the path. What's over here? That's a methyl group hanging off of carbon 3. That's my first branch. Then I walk down the trail. Number 4 has another fork in the road. There's 2 ways to go. One leads to a chlorine, another one leads to bromine. So on 4, there's a chlorine, and on 4, there's a bromine. Bromine. Walk down the main trail, number 5, fork in the road yet again. On my left side, there's a methyl. On the right side, there's a 3-carbon group connected by the middle. 3 carbons is peanut, I'll eat peanut butter, propane, but it should be connected the normal way for propyl. This is the isomer. Coming off of carbon 5 is isopropyl. Number 6, 2 forks in a row as I walk down the main trail. Bromine on my left off of 6. And on the right side, there's an ethyl group off of 6. I'm almost done. This is a long trail. Go to carbon 7. There's 1 branch. It's a methyl branch. And then 8, 9, I'm done. Walked that whole trail, found all my groups. What do you do with these? Alphabetical order. Give myself a little more screen space. That works. Cool. I wonder if I'm gonna have enough room. It's a long name. Well, thankfully, every time the same group appears more than once, we only say it once, but we add a di-tri-tetra prefix in front of it. All right, so I got an M, a C, and a B. Ooh, B's probably gonna win. Another M. I have an I. Yes, the iso gets alphabetized. Isopropyl. B. B wins. How many B's how many bromos do I have? I got 1 here, and I got 1 here. There's only 2 bromines in the molecule. So the name begins, where are those bromines? On 4, 6. Pair of them is dibromo. Cool. And then we had M, a C. Oh, C's got to be next. Another M and an I and an E. And an, yeah, C is next. Well, you have 1 chlorine, and it's on, whoops, it's on 4. It's a dash to separate a letter from a number. It's a chloral. Took care of the chlorine. I'll mark it off my list. Then I have an M, an I, and an E, and another M. The E wins. So next is 6-ethyl. And I'm left with an M, an I, an M. There are 3 M's, sorry. I is alphabetical order next. Stick in the 5. Where's that isopropyl group off of carbon 5? And then all I have left, yes, are 3 methyls. They are found on carbons 3, 5, and 7. And there are 3 of them, so throw in the tri-methyl. Those are all my prefixes, all my branches. That's a highly decorated molecule. Follow with the parent. Non-ane. Oh my goodness, we did it. Now let's take a break. Thank you so much. See you in the next video.